micro beard. So let me try to share my screen here. This session is basically going to be done on Micrometer, so Mentimeter. So if you want, you can log into here and you can paste questions that we can address while doing the session. Who am I? Well, I'm here to talk about muscle services, microservice, and monolithic architectures. I'm an MSc. I'm a senior software. I don't care about any of this. Who am I really? I'm just some guy from Void Software. I'm here to talk to you tales from the trenches. I'm a developer. I write code. I deal with people and problems, too many people, too much problems. And I'm here to just give you a little bit of my experience. I'm not 100% true. I don't know all of the answers, but I do have some experience and I want to share that with you today. So this is a session of tales from the trenches. Who am I to talk to you about microservices or monoliths? Well, I have developed during 87 long months a monolithic solution for Silicon Valley. In 17 months, I'm currently doing a microservice solution for all of Germany. This is the experience I'm going to bring you. All of the things I'm going to tell you have been based on past events and things that we have learned over time. So this is a page that is going to stay open. I would like you to try to, over time, evaluate what you think in a real world environment, which is the best solution. Best. That's hard. This is actually, you can give a 0 to 5 to each one of the lines, do whatever you want. We want to revisit this later and understand how you feel about this. Because if you ask a server developer, well, this is what happens. People ask Bart Simpson, say the line, and he says, which is better? It depends. That's what happens with pretty much every single decision in software. Everything depends on the conditions, the scenario, everything else. I would probably go back to this in multiple scenarios. Yeah. So, monoliths. Here is the page where you can then post your questions and give me your inputs. When we're developing a monolith, people are innocent. They have their user story that says, as a user, I want to do something so that I gain value. And what do? We immediately jump in and do code. We develop a solution that is straightforward, streamlined, and it works. And then someone comes with a second user story, a third one, a fourth one, and we end up building a release. This release eventually goes into production. And usually for a lot of small companies, we don't care about it anymore. But that's really not what happens when you have a successful solution or something you have to maintain over time. Time is a horrible variable here. Because things don't last the question of they don't last time. They don't last the test of time. Over time, you get more users, you get more load, you get more requirements. You say when someone uploads a file, we now want to have an OCR that will scan it, and people, let's do a streamlined, let's do a synchronous. It doesn't scale. Scaling is a big part here. There are two different types of scaling, vertical and horizontal. Vertical, going up. So we want to make things bigger. You need more load, you need to support more people, throw a bigger machine at it. It works. It absolutely works until a limit. There is a limit to the amount of memory, the amount of cores, the amount of processing system, everything that an actual monolith can have. And what actually happens is people try their best to adapt the existing monoliths to work in a clustered environment. So for example, instead of having one monolith, you might have what is almost in the direction of a muscle service. You might have 2 monoliths, 3 monoliths. It works, but how do you spread the load? How do you balance this? It would be as easy to say, just spread it equally. Load 3 different services of the same monolith and let it run wild. But systems are not usually simple to their own domain. They have a lot of domains and a lot of things going on. So we have a service that intercepts files, that does the OCR, but suddenly someone says, I want the monthly KPI. I want to receive an email every month with the number of pictures that have been processed by the OCR, or the amount of pictures that have been deleted, something that happened. And naively, you start making a synchronized thread, you throw it inside the monolith, and the monolith does a certain behavior except once every month. At the first day of the month, it triggers a report. It triggers something that goes to the database, crunches a bunch of numbers, and it's heavy, really heavy. You can't really avoid this. There are ways to try, and a lot of attempts have been done. For example, feature flags. It would be quite easy to say the KPI enabled true or false in the configuration. Simple, it's a Boolean. Anyone can do a Boolean thing. The issue is maintaining that. One flag is simple. 15 flags is hard. 500 flags is a normal solution, and everyday solution. That's what happens. And hosting wise, it's a nightmare to be able to understand all of the implications going on with this. There's also the horizontal scaling, which is throwing the more machines at the solution, which is kind of what the people thought of when they wanted to do microservices. I'm probably getting ahead of myself here. With microservices, you are trying to decouple a lot of the data from each other. You're trying to make sure that each service is isolated from each other. If you're using a monolith with multiple instances, they usually share the same data, the same database. And that is making a bottleneck. That is making a point where you can't really grow or you can't really move because one system, one operation will make the whole system and the whole solution slow. More and more over time, you're trying to add different scaling techniques, trying to add different ways to make the system capable, and you're just shooting yourself in the foot. One of the examples I do have is the way that the database was partitioned in the monolith that we were using. So we wanted to have a partitioned database, and this partition is done logistically, not MySQL. You could easily tell your MySQL, easily. You could tell your MySQL, please, this is a clustered environment, consider this as a cluster, which is a pain in the neck for hosting to actually to maintain. What the people did in 2001 or 2 was, we will divide the database by user ID. All the users from A to J are in one database, from J to Z are in another. It's an easy way to split. Because at one point in time, someone said, this will never relate. We will never have a relationship between databases, ever. Of course, 10 years later, someone says, I want to be able to share details from one user to the other. Oh, no. And actually, in the solution that is currently live, it has been live for a decade or more, when you try to scan data, it will logically go through all of the data sources and compile into memory the data to just give back because of some technical debt that was imposed by the people designing it. They were not doing a bad decision. They did what they could do at the time. They did the best that was to their knowledge at the time. Microservices could be an approach to this, but microservices also bring other problems, huge problems, and a lot of maintainability problems. For example, how can we go from a monolith to a microservice? Luckily, in the Siemens Germany company that we're working with, the people in the company have a lot of knowledge of the domain. And that makes it very easy for me to understand how this should be split. Let's take a big solution. How do you want to split it? You could easily go by the business structure. There are 3 different companies, we can divide into 3 different microservices, 3 different monoliths, do whatever you want. You could also do by the subdomain or by the business logic. You can check there's a user, there's a customer, there's an invoice. You can have the user service, the customer service, the invoice service. That could make sense if you are naive and don't understand exactly what's going on. The people who actually built the monolith, they are the people who know the issues. They are the people who have the knowledge, the background of why we did these decisions, why they are wrong, and what can we do to actually make them better. When you are hired as a company to say, I have a monolith, I need a microservice, you don't have that domain, you don't have that person that was there before. But then again, you already have a problem because the customer said, I want this solution. Do you really need a microservice or do you need a solution to your problem? And that's pretty much what we should be doing as engineers, finding solutions and not going deep into what the customer asks. Nonetheless, for microservices, another place where you can ask questions, the issue is a completely different one. We're trying to structure our code in a decoupled way. And when we decouple it, this is a point with, we can have a length arguments. It should be 100% decoupled. One service should affect the other. One service going down should not affect the other existing. So they should have their own database. They should have their own data. They should have their own service, and it should be isolated from each other, which is a pain in the neck if you have, for example, one service that treats uploads of files and another service that treats OCR. The data has to go from one service to the other, has to be a lot of duplication, but it works. We're able to scale one, we're able to make one bigger and not affect the other. We're able to make one smaller, which is also sometimes a requirement. We don't care about the KPI, the report coming in. We care that it comes in once a month, but you could have the smallest service possible. We don't need it to be heavy. We need it to work. What we do need is that the service that we're actually giving to the people that has zero downtime, that has high availability, that works instantly without having to wait or have the effective downtime costs. So there's a whole view of how will we actually go from the monolith to the microservice that makes the issue complicated. And then you have all the layers, because it's easy to have in my code a package user, a package invoice. I change the invoice to something that now uses a first name, last name, and middle name. I compile and it says user doesn't have a middle name. The compilation fails. It's all in the monolith. It all works on compile time. But if we're working with microservices and each service is decoupled, there is layers between them. There is a DTO that one sends and the other one receives. And if these contracts are not matched, they don't compile. The contract, one person compiles one microservice, the other one compiles the other one. They both go into production and they have to match. And then there's a bug. It doesn't work. Usually it should be as simple as looking at the machine, I SSH to it, I check the logs, it shows me what the error is. If I'm in a multiple clustered environment that has 15 nodes of a ticket, 10 nodes of user, and some guy says, I have a log, what machine do I have to log into? Pain in the ass, it really is. There are mechanisms to this, the file beat mechanism, where we have a service where all the clusters send their logs into, and then we go to that one service to actually, we're just adding more and more and more layers into a simple problem, into something that somebody wanted a service that you made a request and it responds in time. And we're just making it very, very, very complicated by adding all these layers. The problem with the layers makes it hard to debug, hard to understand where an issue is, where information comes from. Because when you're dealing with a microservice, you are dealing with the whole monolith, the whole logic, plus all of the hosting architecture, all of the scalability issues. You have to have, if you design it as a square, the vertical and horizontal knowledge. And no one has all that knowledge. There are people who are very good at hosting. There are people who are very good at architectures, at programming. You actually need a team to build a microservice. And microservices usually aren't there to solve small problems. They're there to solve problems with big, big teams. So you have lots of people interacting with lots of different services that all need to coordinate, and hopefully everyone speaks the same language, not one person speaking Japanese, another one speaking German. Then things get really complicated because some cultural things that go over. So microservices end up being the same work as a monolith plus the extra. And what is the advantage? It scales. Is that a good advantage? Is it better than a monolith just because it can scale better or not? I'm not here to answer that question. I'd love to, but the truth is we live with monoliths and we live with microservices. They are all around us. And monoliths, better or worse, have been there for decades and will be there for decades. They work. My boss, he is a strict advocate of saying monoliths. That's the way. If there's not a reason to actually waste your time, stop and go into microservices, don't. For example, this Germany company, they were the the leader of the market for about 10 years using monoliths, developing and supporting monoliths, until one day they said, it doesn't work. We now need to go to Berlin, we need to go to Munich, we need to support all these different people all at the same time. And well, they stopped. They actually stopped for 1 year developing new code. They were re-implementing the whole solution with microservices and trying to make sure that the solution did exactly what it did before. The same-ish, get redesigned, no tech depths, cleaner solution, but it has a cost. And what they want is to have the advantage of being able to have this product and send it out to all these different tenants, make sure that the services are multi-tenant, that they are able to have 15 servers for 30 different customers, which has a cost. And my presentation is pretty much this. Is there any questions? Please. How do we deal with the complexity of the microservice? Should we delegate the complexity or? Services, or are you actually just making solutions for each service? Ideally, we would share. In the case of the Germany solution, we have two different native-based approaches due to mixed knowledge of the team. So one was using Spring Boot, the other one was using Quarkus native, and they both work in tandem. Ideally, we want to use similar infrastructure things. You can't exactly program a 100% decoupled solution, a monolithic microservice solution, without having locks. In that case, we're using Hazelcast, for example, and some services like Elasticsearch. So that these are common solutions, and to integrate with these solutions, we use common libraries. Ideally, we want to reuse code as much as possible to keep that as the compile side, but we release things are annexes, things that get tagged. So when you're actually building a microservice, it's isolated and independent. What the biggest challenge we have is pretty much the question you're asking. How do we divide the domain? How do we make sure that the knowledge is there in that person? And ideally, we do have one person who is the system architecture, the microservice architecture, who has this view of who gives what to where's the responsibility come from. And his job is the hardest of them all, to understand who does what, when, where, who is in charge of responsibility. And simple things like an enumeration that is lowercase cost a week to fix. Changing the enumeration from lowercase to uppercase, plus changing the two services that consume this, plus changing this guy who is the external guy who's actually migrating data into the database. It's a lot of layers. It works. It's what we have, but it's not pretty. To answer your question? You're welcome. Thank you. Anyone else?
Just a second. I need to go to you, otherwise the other people are not going to hear. Just a second. I'm going next to you, and then I present myself. Can all of you hear me?
Yes.
Quem é o primeiro? Just a second. Epa, parece aqueles repórteres RTP. Okay. Just a second, please.
Can you speak? So, now can you hear this time? No? Can you hear me? Okay. So, from your experience using microservices, which rules can you define as the golden rules to have a successful project with microservices. Looking at the engineering side of use, but also looking at the leadership and also working with different teams.
Could you make a smaller question, please? Yeah, migrating an existing system to a microservice is also a pain in the neck. There are a couple of different approaches. One is the string or fake, where you're doing it incremental, and the idea is you can always revert. Another one is UI composition, where we actually have the same UI served by two different services at the same time, and you're just slowly trying to migrate all the endpoints to the rest. Ideally, you could do what the guys in Germany did. You can stop, you can freeze time, you can freeze requirements, and you can just push forward. That's not the reality. So what exactly can you do? I don't have that answer. How to deal with people and leadership? I like Scrum. I hate Scrum, but I like Scrum. Scrum can work. What I would say is we need a framework to deal with people, because the biggest issue with software development is communication. Biggest issue with dealing with people is communication. Then what we need is to synchronize people. And your last point was?
Leadership and also teamwork and engineering.
Engineering. So it's a matter of engineering. I've seen that techniques to actually analyze what needs to be split. Like you look at the logs of a production server. You use metric clustering techniques to understand which logs are being printed more times or less time, and based on that, you actually divide the microservice into the service into microservices. It can work. It might seem a bit naive, but if you have no knowledge of what's going on, it might actually be the best approach. Because why do you need to make a whole solution divided into domains when only a small INSI bit is actually the one that is causing the performance issue? Maybe you just need to extract that. Engineering wise, it's a problem. It's a big one. What I'm trying to say here is the approach of using microservices is more costly than not using it. So the benefit of being able to scale, you may evaluate that benefit for yourself. Next.
Okay, knowing what you know now, if you had the power and you can go back in time, would you make the project you're currently working on as a monolith instead of microservice? And conversely, the previous project that was a monolith with Silicon Valley, would you have made that into a microservice or kept it as a monolith?
Yeah, if I had the chance to go to the current one, I would probably do what I just said. Some of the domains don't need to be extracted. The people who are architecturing it want to make it reusable. So everything is a dedicated service that can be reused, which makes sense for the current domain, for the current problem. New customer, new requirements, new user stories, it might not make sense. So probably it would be better to have some of the logic into a bigger service and just decouple what needs to be decoupled, which was pretty much what I was saying with the previous one. The monolithic approach did work in most situations except a few scenarios, and those scenarios needed to be extracted. I think that a dynamic and a hybrid solution, so probably going into the muscle services, whatever service is stronger for that solution is the best. Because we don't actually do monoliths. We always try to make it a bit more dynamic. And we don't usually do pure microservice. There's always a bit of a monolith into there. So everything is always a hybrid approach.
Seems like you're saying that in the real world, the best option is both, right? So this yes and no binary answer seems a bit over the top, almost like a trap.
It is. It depends. The matter of it's somewhere in the middle. There's always some sort of solution that actually works, and that's what we've been doing. We've been trying to make the monolith work with flags, with approaches, splitting. None of them are best. None of them are worse. It's a matter of looking at your domain, looking at your problem, and trying to evaluate which is the best at that particular time.
Share code between them, so you maintain the same consistency, or that's too much of a goal, impossible, intangible goal?
That would be lovely. That would be very nice.
One repo to rule them all and still microservice.
the one repo to
Right?
that would be lovely, because one of the issues also is the layers. I mean, you want to release one service, you don't exactly understand all of the effects that it has on all the other ones. You do a breaking change, you have to change the API version, you have to do all these. It would be very, very easier to just take the whole service and redeploy everything new. Which just take the repo, what's in develop, push it into master and go forward. But people work in different teams. People want to tag their artifacts independently. They want to be able to have a bit more separation. So we don't do that, and it brings costs. It brings a big cost. The whole compilation issue is an issue. The fact that it's not compiling against each other's services. Test-wise, on the monolithic approach, you develop, you have unitary tests. Please tell me you have unitary tests. And we then do integration tests. So after you build a solution, you run it, you set it up, and you start making requests against it and make sure everything is okay. With a microservice, you have to set up the whole scenario, everything together. And that's the integration. The cross integration tests are hard to maintain. From my perspective, someone gives me a user story, I implement it, I test it, it works, I send it into production, and it's broken. Why? Because it didn't compile against everything, because it didn't test, and all this just brings a huge cost. Are we willing to pay it to bring the advantage? And no more questions. People remote. Thank you very much.
Welcome, Ivo. So now, after the good presentation of Lee, awesome, I will say awesome, okay. Celso, now you have a bar up too high. Just messing with you, just to chill. Now we will have Celso Santos. He's going to talk how to be more or less a human while doing a code review. Okay, thank you and enjoy it.
Well, hello, everyone, the ones here present and the ones at home. I hope everyone can hear me okay. Yes, I'm being signaled okay. So let's start this, share my screen. Can anyone confirm it's working? Yeah, getting excited. So first of all, and to start with, let me just take a picture because my kids don't actually believe people want to hear what I have to say. So I'll start by that, please. Bear with me. That is if the phone wants to collaborate with me. It's not a Windows phone, but it's a sucky phone. Sucky. So say hi, please. Yay. Yeah, they're going to be so thrilled. Yeah. All right. We have some things on screen. How do I take that out?
I think you can move that.
Do you think?
Right.
Maybe to the left. Oh, okay. This one works. This one works too. Okay. So let's go ahead. The subject I bring here today was actually more or less of a challenge from our friend Antonio. He told me that he needed someone to speak at an event, and he wanted something that brought up a discussion. And boy, oh boy, do we get discussions on code reviews. So yeah, that's essentially what I'm going to be talking to you about today. It is highly based on the work from Michael Lynch on his books on how to do a code review like a human or something to this liking. I do have a link in the final. I don't know exactly how I'm going to share the slides with you, but Antonio will eventually say. And so if this works, it works. Basically, the agenda is more or less this. Let's start exactly by who the hell am I? And who am I to speak to you about code review? Well, my name, you guys all know. I've been doing some work around IT for some time, whether that was coding or working as a pre-sales engineer or just giving a helping hand at whatever problem the colleague had. There's one thing that we could never really escape, which is that we work in teams, and that those teams, they all need to be on the same page. They all need to know how to work together, and essentially they need to be like a well-oiled machine when doing that work, much like in a factory. So I've had a chance of working with quite a few technologies in the past. Doesn't really matter for this topic, but I kind of enjoyed most of them. What I didn't really enjoy was some of the people I worked with. Does anyone here, well, I'm guessing everyone has at least one colleague that they don't like to work with. Yeah, I'm getting a lot of yeses. Okay, so just getting a few things out of the room. Code review can be anything from a one-to-one session to whatever the hell Elon Musk did at Twitter for the past couple of weeks. There are essentially two participants in this process: the author of the whatever changes it's being pushed, and the reviewer or reviewers that effectively decide when that code is ready to be merged into the team's code base. And the primary purpose is, well, the primary purpose is to make sure that the overall health, the overall quality of our code is increasing over time and not actually decreasing. But it's also an opportunity for us to do some knowledge sharing, either me as a reviewer learning whatever that author did. Maybe they had some nice trick up their sleeve that I didn't know about. But it's also an opportunity for the authors themselves to learn from usually more senior reviewers, though this is always not the case. So, I mean, there are some clear benefits, right? Knowledge sharing between authors and reviewers, but also catching bugs before they ship, right? It's a lot nicer to catch the bugs before they actually get into the code than when they're in production, and suddenly you have a bug report from a client say, hey, yeah, that trade didn't went through. So it's not very nice. And a lot, of course, another advantage is that this way you are able to maintain some consistency, pardon my English, it's a bit broken. You get some consistency between the different code bases or even different teams. This may or may not be true depending on how you structure your code. There are people that work in huge monorepos. Let's look at Google, for instance. All of their products are more or less on the same repo, which is apparently a pain in the ass to work with, or so I've been told. But yeah, it also allows for same practices between the different teams. And this way you can effectively move team members from one team to another on a whim, if that is the case. Right, so we've all done code reviews in the past. It's a simple thing, right? Well, no, it's not. It's not because, well, when an author sends you a change list, right, they're usually pretty confident that the solution they have is the one that's working. It's the one that's going to be committed. And it's like, F yeah, I got it on the first try. Well, no, okay. But then the reviewers come out and then they give you like a huge list of all the things that are wrong in your code. And oh boy, depending on the person you're working with and the level of confidence you have with them, they can see that as either just general criticism, or more generally, what will happen is that they'll think that you're attacking them personally as a coder and as a programmer. And when we get to that stage, well, things usually just go downhill. All right, so it's usually, you know, it's easy to misunderstand what's being said because you're essentially doing reviews usually on writing, so the other person can really see your body language, your tone of voice. They don't know what's going on, and if you are not extremely careful with what you say, then you risk making the process a lot harder for everyone. So much so that this gentleman here, Philip Greenspan, co-founder of Ars Digita, I'll be honest with you, I didn't do a lot of research on the gentleman. I just found his quote funny. He basically tells that programmers are very unlikable people, and that in aviation, people who greatly overestimate their level of skill are all dead. While I cannot agree with, I cannot disagree with the second one, I certainly cannot agree with the first one. It's not like programmers are unlikable people. Well, some programmers are unlikable people, but that's a different problem. All right, so what we're going to be discussing is how you can improve the reviewing process as a reviewer, which doesn't exclude the author from having some responsibilities. Namely, authors should keep their pull requests as small as possible, and add helpful commit messages instead of committed changes, fixed something, and other helpful messages. They should also write a description, a full description of what they're trying to do with that pull request, and respond to comments immediately, because, I mean, let's face it, if reviewers are kind enough to go and review your code, you're theoretically not moving on to another task until that one is ready, and that one's not ready until the others say it's ready. So you should be able to respond almost immediately to this. If authors follow these practices, ideally things will be a lot faster. I don't know how well or how poorly this can be seen here and at home. These are just a couple of examples of someone on my team, which I'm really proud of, that she really got the message right, and she really does really descriptive commit messages, even the ones that do not get merged. So it's always a plus. All right, so now what can we actually do as reviewers to make things easier? Well, first and foremost, we should let computers do the boring parts. I mean, this one is obvious, right? Humans should be involved in the process as late as possible. Reading code is hard enough, and when you get constantly interrupted by Slack notifications, some email, someone tapping you on the shoulder, hey, saw the show last night. Yeah, it's not easy to to go from one thing to another, and context switching is hard. So when you automate things, you can almost immediately ignore quite a whole set of tasks that you do not have to worry about anymore. So don't squander your attention on stuff that you can automate away. So of course, before involving the human, we need to make sure that the pull request is ready, right? It goes against the author rules that we just saw. It's of course working, right? The author tested the changes and it works, which, by the way, doesn't always happen. They just commit and hope for the best when the tests do come. And namely that it also has tests, right? It's like a big no-no if there's no tests to it. And finally, before we actually involve a human on this process, automation should say that it's working. Should one of these fail, it means that you have a problem. You shouldn't have to bother anyone else to review that code because it's not ready. So look for things that you can automate away. Test executions, style checks, whether or not there are some security issues on the code. What you can automate away, it's really up to you. You can do just simple build. You can go from code to a container and test that the container runs and that it doesn't have any vulnerabilities. I mean, it's up to you. Plus the instant feedback, it's also a lot nicer to get. I know that I prefer being told by a bot that there's something wrong with my code than another colleague. It's kind of a bit of a shame. When you have, hey, you forgot a comma. Thank you. Yeah, stupid errors. Everybody loves them. Okay, second one, also an obvious one, settle arguments with style guides. we've all been there. Should we use Egyptian brackets? Should everything be in the same line? If it's an if that it's just a single line, should it have brackets? Should it not? You can waste a lot of time with this kind of discussions. So of course, a consistent style is important, but it's not during code review that you should be worrying about this. If you have one of these issues, you should talk it out with your team, discuss how you want to do it. Usually the options are you either use an existing style guide like the ones from Google, though you will be constrained by whatever Google feels is the correct approach, which may or may not suit your needs. You can create your own from scratch, but not advised. And the third one is the hybrid approach. Of course, take something that's already there and change what you need. Simple and a no-brainer. Number 3, and probably one of the most important ones, start reviewing immediately once you get the notification for a pull review. And when we say immediately, it's not like I got the notification, I need to drop everything that I'm doing and go and check that. Okay, it's more like, okay, I have something to review. The next break I have, or the next few minutes I have, I should take a few minutes, go and review that code. Why is this important? Well, code that you've been asked to review is potentially finished and ready to be merged. And by its own definition, code that is potentially finished should have priority over your own. Plus, when you do review quickly, you create a virtuous cycle where reviewers will act more in a speedier manner. The authors will also reply in a faster manner, and then this also incentivizes that you create smaller and well-behaved pull requests that are easier to review, and stuff that usually took you like half an hour maybe now takes you 5 minutes, 10 minutes. And so by taking this approach, we basically ensure that people are not getting blocked by your tasks. There is certainly the case where you have some story that involves a number of certain tasks. Maybe you're splitting work between front ends and backend developers, and then you have the case where you have either backends or backends waiting for one another to be able to move. Then the sprint ends and you have to deliver code and it's not ready. So not a fun deal. Another issue with slow code reviews is that depending on how big your code base is and on how fast and frequently it changes, it may potentially become an actual blocker when it comes to then integrating the code back into the master branch code base. Thank you. When reviews start to get slow, how does that usually get handled? Well, there's usually the typical strategies for it, which is increasing the size of the reviewer pool, which may involve bringing people from other teams which lack the correct context or whatever is being done in that specific issue. Plus, the fact that you're adding more people just makes it easy to brush it off as someone else's problem and not your own. Another frequent strategy to deal with this is just creating integration branches. I think we've probably all been there before. Seems like a good idea at first, but then you just end up with a huge pull request to commit with 500 files changed and some 2,000 lines or something like that, if you're lucky. Or you're just getting more nagging either from automated tools or from your manager tapping you on the shoulder and telling you, hey, come on, speed that up. Okay. All of these strategies don't actually contribute to make the process faster. If anything, they may actually contribute to make it slower. So by all means, do start reviewing immediately. Ideally, maximum turnaround should be 1 day, maybe 2 if it's a contentious pull request. And also, if you're struggling to be able to review their code, let your colleagues know, give them an offer, a chance to offer their review to someone else, or essentially, just understand that if you're declining reviews too often, maybe, maybe you guys are doing too much stuff at the same time, or just not completing tasks and getting really pushing things as they come along. When we're actually doing the code review, we should start high level and work our way down. What do I mean by this? We shouldn't overwhelm the authors with a set of comments right from the get-go. Okay, we should really focus on things that are, let's say, more critical in terms of ensuring that that is a current solution, or the correct solution, or the correct alignment. So, if you already spot quite a few issues, just start with the bigger ones on a given round. Start with those ones, wait for the author to review those, and then work your way down until you just have maybe a few minor notes to give, at which time it doesn't really matter. You shouldn't be taking much longer to get to a consensus. Yeah, and that's, sorry, I forgot to pass the slide. Just saying the same thing. Another point, which is be generous with code examples. Another way to really facilitate and speed up code reviews is just, if you are already suggesting a change, why not go the extra mile and just give a code sample, okay? Even better yet, if you're working with something like GitHub, which actually supports suggestions for the code changes, go ahead and do it. No need to make the author waste another round on code when it's something that you've already told them how to do, and you already do. On the other hand, if you write a lengthy example and you suggest too many changes, you may actually sound a little bit pushy. And in that way, if it's code that you're changing just for the sake of changing, it's your personal taste or whatever, it's not ideal, right? So do go ahead, give code examples, or even better, code suggestions that can be merged right away. Avoid saying you, and this one is pretty easy. When you give feedback and you frame it in a way that you say, you shouldn't be doing this, or you forgot to place a comma or something like that, or you're not thinking of the solution properly, it's very easy, again, to take that as an act of aggression, which is not the case, right? So one way we should really mitigate this is by saying we. Okay, we should move this, or we should rename this, or whatever, or even better yet, why don't we do something, or this variable should be renamed something. And so try to take the focus away from the reviewer and more into the code being reviewed. Another one, which is, and it kind of ties in with the last one, which is framing feedback as requests and not commands. What do I say by this? Again, if you go ahead and you say that you should move that class to whatever subdomain, it's not taken very kindly. If you say, can we move this class to that other domain, then you can generate a discussion around the topic, and it's actually more productive than just sounding like you're giving out orders. Orders will usually get you some sort of pushback, either a simple no, or whatever other thing comes to mind for your colleague at the time. So when we frame things as requests, the conversation immediately becomes a lot more civil. Just kind of a related subject, I was reading a paper some time ago that suggests that females naturally do this better. I wonder why. Same thing happens for the other topic about the way that we push out messages. Females have a way to get things done a lot faster than males do. Yeah, I see some nods. The same thing, by the way, the same thing happens with personal assistants. Males will usually comment things as orders. Females will usually actually terminate with a thank you, which is a nice thing to note. Okay, we're running out of time and a bit long. So point number 8, sorry. Tie notes to principles and not opinions. So whenever you give a note to an author, explain why you're suggesting that change and why. You know, instead of saying we should split this class in two, maybe try something like, you know, this class right now is responsible for downloading the file and parsing it as well. Maybe we should split this into a downloader class and a parsing class according to the single responsibility principle or something like that. You know, just frame it in a way that it's hard for the author to really push back or to disagree with something that's already set as a standard practice in the industry. Another good pointer is, of course, the team's documentation. And when all else fails, Stack Overflow works too, but do be careful with the answers you choose. So yeah, be warned. Now, offering sincere praise is one of those things that is easily overlooked. Whenever someone did a good job, you know, you just expect that to be their job, doing a good work and stuff like that. So we don't often say that, okay, this is good work, or just an emoji clapping or whatever, just whatever works to make things easier. This is particularly important if you're working with a junior team member. These guys can get pretty nervous by nature when they join a team, especially if they're told that that team is mostly filled with senior developers. So do make them at ease, do praise their work, and do find good things to say about the code, not just like on the slide before, where you just don't need to obfuscate the code. Final one, well, almost final one. There's still another one, which is granting approval when fixes are trivial. Whenever one of these conditions is true, just go ahead and grant approval, which does not mean that by granting approval, you shouldn't check whatever was committed next after that approval. It's just a way to speed up the process and not get stuck waiting for approvals. Some teams do have you know, stuff like 2/3 of the team need to approve before it can actually be merged or something like that. So go ahead and approve whenever it's minor things. And now it's the final one, which is also an important one, which is being able to handle stalemates in a proactive manner. What are stalemates? Stalemates here, we're talking about places where there can be no agreement on a certain issue, right? You're not signing off those changes until things are changed. The author doesn't want to change them. So yeah, do start to recognize when you're heading in that direction. There are usually some indications of it, which is that the tone of the discussion is growing tense or hostile. The other one is actually that the number of notes is actually going up instead of down on each round of review that you do, or you're not even getting an answer to anything that you're saying. So what can you actually do when it happens and when you start to recognize that issue? Well, step one is option one, of course, talk it out. Go and meet the other person face to face, pair program, over Slack, whatever works for you. Just have a one-to-one conversation and try to get things working. Well, maybe it's not one-to-one. Maybe there are 2 or 3 people involved in the process, but do hash it out with your team. If that doesn't work, maybe you should consider that there was something not properly designed back during the process. So maybe we need to go back and actually do a design review and see where we erred on that side. And if that doesn't work too, there's only two options. You either concede or you escalate. But then you have to weigh in quite a few things, right? You as a reviewer, you have to think about, you know, how bad would it really be if you approved that change list? Is that code that would potentially destroy critical data? Well, if it is, maybe stick to your ground and defend your position. If it's something that it's a background process that, you know, at worst someone will have to debug because it will fail sometime in the future, and it's just annoying because you have to get back to it. Well, there are pros and cons to letting that slide. One is I told you so, right? And the second one is, you know, it's annoying, but it was just necessary to really get out of that situation at that time. So how do we actually recover when any of these situations occur? Well, you only have really three options. Discuss it with your manager or someone that has a similar figure. I know not every company and team has as traditional managers, but if you do have a good manager, should be able to help ameliorate the situation. The other solution is, of course, take a break from each other. You know, stop assigning and asking for reviews from one another for some time. Or if you really want to get down to it, just study conflict resolution and apply all the techniques that come with it. But yeah, that's essentially it. So these are essentially my adapted 11 points from the original author. And as I said, there are some additional resources where I got a lot of this input when this really became needed in the teams that I was working with. I'll try to make this available somehow, but yeah, that's it for me. So thank you. I think we can now open to some questions, if there are any.
Just raise your hand. Okay, just a sec. Oh, wait again. Sorry for the inconvenience.
So sometimes this happens, how to handle big pull requests.
How do you handle big pull requests? If that happens, you have two options. You either decline it and ask people to go back a few steps and you know, reanalyze everything, reassess everything, separate in a way that chunks are smaller, or there will be situations where you'll just have to suck it up and do it. Is it desirable? Hell no. Does it happen? A lot more often than I would like, but yes. So I would say these are the only really two options that you have. Another one, which is if the authors are doing their job well and they are pushing commits in a way that you can actually see their thought process and how they arrived to that change list, it may become easier. And so you can review commit by commit. But yeah, overall, once you have a big pull request, you have a big pull request. There's not much you can do to it. Does that answer?
Oh, yeah.
One thing that I have noticed for a while, and one thing that I felt was when I started, when people ask me, why are you not reviewing? And I was like, I'm to green, to review. How do you advise newcomers to the company or junior devs that aren't familiar with the code base, aren't familiar with the styling that the company wants, how do you advise them to be more proactive and start reviewing sooner, basically?
Okay, so you actually mentioned something about styling and stuff like that. As we said, that's something that really should be in a way automated either by your IDE and your style guides and stuff like that. So that should be the easy part. The other one is, even if they are not familiar with the code base yet, that's the perfect opportunity for you to start becoming familiar with it. Start following tasks that are being assigned to other more senior developers, see what they are doing, see the kind of little tricks that sometimes those developers do. And either way, if you are already on the reviewers list, usually the rest of the team considers you as a good enough team member to be already in that forum, right? Even if you're just a newcomer to the team, you probably spend some time learning the code base, maybe doing a couple of changes. In my company, we actually have people pair program for a week or two with other developers so that they can understand why we do the things the way that we do. And also to explain them whenever they see a solution that is not ideal according to their eyes, and explain them why it is, or why it hasn't been tackled yet. But otherwise, even if it's just a junior member, starting to read the code and be present and see what others do is actually the best way for you to be done with it. What was that all? Did I?
Everything.
He's got a mic.
Yeah, it's easier like this. The hardest thing for me when doing a code review is to stay human, because you said three different steps that you have to check, you have to work, you have to test it. And then when you're reviewing someone else's code, you see, how did you test this? It doesn't work. How do you deal with that? With people who are just sending it into production, making the commit, and the test will see if it failed or not.
There's no point in walking around the bush, right? So if people are not testing their work as they should, you can just straight up tell them that this is clearly untested code. And again, it's not a personal attack, even though a lot of people will take it like this. It's just stating a fact. That's code that's not been tested. So there's really no easy way to say this code that's not been tested has not been tested. It doesn't mean that, okay, you're an idiot that didn't test. You thought that for yourself, but you say, please go back and test the code before recommitting. That's all you have to do as a human. Using please usually works. There's no other.
Can I ask one thing?
Yeah, go ahead.
By the way, for those who are online, you can also make questions. Okay. The first one is, do you think code review is something cultural in a company, since you have been in such places like pre-sales and stuff like that? Do you think that is something related to the culture of the company, or is something else? Or is something that it can be?
It's not so much about the culture of the company. It's just about knowing what works and what doesn't work in these sort of processes. It's no coincidence that we have processes like Scrum and Agile and others. They, well, mostly work, right? No process is perfect, but processes, once implemented, are implemented for a reason. They usually work. And the same thing is true for code review. If you make these as standard practices rather than a culture thing, then those are your standard practices in the company, not in the team, not as a way that something that some people do, other people don't. It really has to be kind of enforced. And if you have, I shouldn't say this, but if you have a team of assholes, then maybe you should reassess your teams. But yeah, it's not cultural. This is just part of knowing how to do proper review. It's not forgetting that there are people on the other end. Those are not robots, and apparently people have feelings.
Just following this, so what are your thoughts in a situation where you already have a good team? They are not assholes at all. They work really well together. But you reach a point or a stage on the company where you are, and you need to deliver it really, really fast. At this point, you know how people are. I trust you. And in less than 5 minutes, you can see 50 changes. It's impossible because you want to cover that. But so at this stage, do you still think it's not a cultural thing, or it is?
No, it's still not cultural. As we said, if this is part of the standard practice that you, let's say, just don't accept a commit or a pull request until it follows some standard insane practices, then that's something you should do. Should you really look at this as a cultural thing? I don't think so. Again, I'll go back to this is just doing proper code review in a same process. But there are times, of course, where some of these practices will go out the window because you're pressed for time, right? You'll not be patting your colleague on the back like, hey, nice job, you know, just, hey, get this done and get it over with because we have a deadline. But overall, even in those situations, once these sort of practices become just standard and ingrained, they're naturally, and everyone just works like that. Which doesn't mean that you'll have the occasional person that will push a pull request with like chore, and then you had a what without any sort of description, and you'll have to look into the code. Again, it's not. It's one of those places where you can really be annoying and go back and say that, yeah, I'm not accepting this until you follow these practices, or, you know, you understand that everyone's a bit pressed for time, and for that time only, you'll close your eyes. Though you shouldn't.
Either of you ever do something like that? So you speak in the perspective of a code reviewer that needs to be a human for the person that is doing the code. But let's say the person needs to do a thing, I'm going to call it a thing, or a feature, a thing. And on that thing, there is a scope that is very narrow. Okay. When it's doing the narrow thing, it comes to change 105. Okay. So should at this point the code reviewer call an asshole to the guy, or in this place, how do you think the code reviewer should act and the other actor should act?
Yeah,
you understand my question?
Yeah. So basically, if you have a narrowly scoped thing that needs to do a lot of changes, how do you handle that, right? As a reviewer or as an author?
Oh, just I want to figure out.
Right. So I mean, again, it really goes back to Lee's talk. It depends, right? You can get a pretty narrowly scoped thing that ends up touching a lot of places, I can certainly think about changing just one configuration, but having to do that across 100 microservices. It's very easy for you to get 100 files changed with a simple change. Of course, if you, as an author, you see that you're maybe changing a lot of things, you're probably not doing them all at once. Maybe you change a class name first, and you fix all the other places. Then you can actually implement the new functionality, and so you get smaller commits. And even though you'll have to touch in a lot more places because you'll be changing a lot of files, smaller commits with a pretty good explanation of what was done in that commit will usually mediate that issue. More questions? I already got the claps, man, so we applaud.
Can all participate. I'm more than free to jump in. Okay? And then go jump. You get the point. Okay, so just a smaller one. You said something cool about we should take the fact and the opportunity to use automated things like on GitHub there is stuff like
GitHub Actions or
not that point, because in that point it's more like a closed stage
Mhm.
of situation. I'm talking more like we're talking more like things in the board that is or things that are doing the link, like that guy said. Sorry, I didn't remember your name. You think that sort of thing can disrupt or annoy the code reviewer at the point that he ignores that threat and off we go?
Yeah, I can tell you by experience that whatever Dependabot tells, I'll just plainly ignore. I don't care. It's nice that you're notifying me that there's a new version. But unless you're telling me that there's some really critical major bug or security thing that needs to be fixed, I don't care. I'll just ignore whatever Dependabot tells, because speaking of Dependabot specifically, it'll just tell you there's a new version. It doesn't care whether or not that version is compatible with the ones that you're using. Now, a lot could be said about the NPM semantic versioning and how it's broken in so many ways. So that's the actual problem with Dependabot, is that in this particular case, NPM, for instance, is broken. But then very often during the automated tests, you'll get something like syntax SonarQube, and SonarQube can actually tell you that it's not the best approach to use that method because it has been superseded by a newer version, or we found out that there was some issue with that, or even tell you that there's like a performance improvements if you just switch up some method. And you can take that as inputs for your reviews and use those as a way to detect whether or not that that pull request is actually ready for review. If SonarQube comes that you have like 3 critical security vulnerabilities, yeah, well, maybe there's not even a point in telling the author that they have those vulnerabilities. Sonar will let them know. So it's really their responsibility to fix and stuff like that. So tools are a way for you to really offload this weight out of you, right? It's something like the difference between method A and method B. It's something that you may happen to know as a developer, or maybe that's news to you and you just learned something. So yeah, there's definitely a place for all of those tools. Do weigh in how many you do have, because then you can end up with, I don't know, having to wait 1 hour before all the automation runs, and you can actually do some review. which is of course also not desirable. Now, when we say automate everything a way that you can, it's like the basic stuff that you do on a review.
More questions? Okay, you are tired, so I'm going to stop now.
So thank you again.